This is a video tutorial for tutorial 5A, question 11. Question 11 tells us y is equal to e to the x ln x, and it asks us to find dy by dx. So to find dy by dx here, we need to apply the product rule. So how do we do that? Well, we hold e to the x constant, differentiate ln x, we get 1 over x, plus hold ln x constant, differentiate e to the x, you get e to the x. So our answer is 1 over x e to the x plus ln x e to the x. They can also be written as e to the x ln x plus 1 over x. So any of these forms should be fine. However, we can go a step better because we do recognize that this part here, ln x e to the x, is just our original function y. So if I wanted to, I could also write dy by dx is equal to e to the x over x plus y. So that may be an easier form for me to use. The reason I may want to do that is when I look at part B, I've got to show that something is true. And that's going to be hard if I keep on getting a lot of terms. It's also going to be hard if I keep on having ln involved, because you'll notice the expression that I'm asked to show doesn't involve any logarithms. Regardless, when I look at what I'm asked to show, I'm asked to show that that x d2y dx squared plus dy by dx minus 1 plus xy equals to 2e to the x. When I look at this, the first thing that catches my attention is that I can see that there is a second derivative here. That means I'm going to want to differentiate again. Again, this is another reason why I'm happy to have the y here, because when I differentiate that, it just becomes dy by dx. Whereas if I had no y, I would have to be differentiating using the product rule or something equally awful. Regardless, let's try and find the second derivative, since I know I'm going to be needing it. This e to the x over x business, I know that I'm going to need to use the quotient rule for this one. So quotient rule, differentiate the first, I get e to the x, hold the x constant, the denominator constant, minus, differentiate the denominator, I get 1, hold the top line constant, e to the x. Whole thing over x squared. Differentiate y, I get dy by dx. So if we compare this statement with what I'm trying to prove, you can see that there's a few differences that I'm going to have to iron out. The first thing I want to have is I want to have x dy by dx. So I'm going to go ahead and multiply through by one of my x's. So I'm going to get x d2y dx squared is equal to e to the x x over x minus e to the x over x plus x dy by dx. Okay, well that's, and that can further simplify to x d2y dx squared is equal to e to the x minus, now where have I seen this e to the x over x business before? I've seen it up here, so that's certainly hinting something to me. I may want to use that later on, and I still have this x dy by dx business to take care of. Now I only have one, I've got plus dy by dx here, so I might want to do something about these two terms. This is not quite right. So keeping in mind what I'm aiming for, just going to delete that away first. Actually no, that's not a smart thing to do. I'm going to bring that back. Okay, might move it later on. In fact, let's move it now. Okay, carrying on. This part here, I think I'm going to, sorry, I realize I've just hidden the part that I actually need as well. remember that I found out previously that dy by dx is equal to e to the x over x plus y, and that y is equal to e to the x ln x. Both of these things are going to be useful. In particular, when I'm looking at this, I also can see that x dy by dx is equal to e to the x plus xy. Okay. So, and sorry, there's one other thing I can notice from this. It's that e to the x over x is equal to dy by dx minus y. So I'm going to make use of a couple of these two here now to try and simplify my expression. So I have x d2y dx squared is equal to, going to keep the e to the x, minus, now e to the x over x is dy by dx minus y, and x dy by dx is e to the x plus xy. So again, simplifying, I'm going to get e to the x minus dy by dx plus y plus e to the x plus xy. Now, you may have asked, why did I do the substitution? Why am I doing this? I'm doing this because I know I needed a dy by dx to get the minus dy by dx to get this plus dy by dx here, and I can get it by getting rid of this e to the x over x. I also see that I don't have any x dy by dx appearing in my final answer, so again I want to eliminate it by using this expression over here. So that was my thinking originally, but it's going to turn out quite nice now, I can see. So let's move that dy by dx over. So I'm going to get x d2y dx squared plus dy by dx is equal to e to the x plus e to the x. I now have my 2e to the x, that's what I wanted, plus y plus xy, let me factorize that to 1 plus x, y. Okay, we can see what we have. Move this over, and I'm going to have that exactly. So at this stage, I'm done. I've shown everything that I need to show. Now, there's another way of doing this question, which may be better, hard to say. So again, just remember I had dy by dx equals to e to the x over x plus y. And if I straight away notice that this means that instead of just differentiating straight away, I say x dy by dx is equal to e to the x plus xy. This makes my differentiation a little bit easier because there's no quotient rule. So differentiating both sides with respect to x, what do I get? I need to apply a product rule to the left hand side. So I get hold the first term constant, differentiate the second term, plus differentiate the first term, hold the second term constant, equals to, differentiating the right hand side, I'm going to get e to the x plus, hold the first term constant, differentiate the second term, plus hold the second term constant, differentiate the first term. Right, so what does this give me? I can already see that I've got my x d2y dx squared, sorry, where'd my cursor go, that I wanted. I've already plus my dy dx, which is good. Now, and I've got one of the etx's here, I just need to get another one in. I can see that I can get another one in substituting my x dy by dx. So this is x d2y dx squared plus dy by dx. Sorry, the other reason I'm going to substitute this out is I don't see any other dy by dx's in my final expression. So I want to get rid of this. So this is e to the x plus, substituting in, e to the x plus xy plus y. So this is x d2y dx squared plus dy by dx is equal to 2e to the x plus y, 1 plus x. This is x d2y dx squared plus dy by dx minus 1 plus x, y equals to 2e to the x. And we are done.